So hello everyone. This is today's question, and the question states that you are given a binary tree, and you have to find the size of binary tree. Okay. So what the size of binary tree actually means? The size of binary tree actually means that how many nodes are there in the tree. That is also like clearly mentioned in the question. The total number of nodes in the tree. So if we go to the first case, then there is three nodes, that is one, two, three. So the number of nodes or size of the tree is three. That is given here. Okay. And in the sixth test case, like in the second test case, sorry, there is total six nodes. So which are the nodes? What are the nodes? The nodes are 5, 1, 3, 6, 7, 4. It is like quite straightforward question. The answer is 6. So we have to just now move to the implementation part of the question. So for that, I am taking reference of Google slide. Okay. Uh, okay. Yes. That's it. So, like, first we will love to know that what the question says. The question says that you are given a node, you are given a tree data structure, and you have to find the number of nodes in the tree. You have to just find that. So to find the number of nodes actually, so how could you find that? You can find that in multiple ways because as an input you are also given you are only given the root node of the tree, the root node of the tree, and you have to find that how many nodes exist in the node. So for that you can solve it. First we will go to the brute force approach. And after that we will solve it like the most optimized way. Okay. So for the brute force approach, the time complexity is big of n and the space complexity big of n. But how can I say that time complexity and space complexity big of n? So uh, let me explain that. Okay. So what can I do? I hope you all know that you all know there are three traversal. There are three traversal. There are three traversal. Okay. Traversal. Okay. One is pre-order, one is pre-order, in order, and posted. I for this video I don't go into the much depth about that each and every traversal. I just use here in order. So you can use any traversal. Like you can use pre-order, you can use in order, you can use post-order. So for now I am only use in order. So what is in order traversal? Your traversal is like if you are given a root node, then first you go to the extreme left of the tree. So to go to the extreme left each and every time, like in the recursion, first you go to the extreme node. Then when you reach the extreme node, it means that there are no other node in the extreme point. So after in that situation, you will add that in any array or vector, whatever it is, root dot root dot a value. Okay. After that, when it is struck into the like null pointer, that is we have reached the left extreme, then we will move backward like in the like as the backtrack to, and after that we will go to the right children. Go to the right children. So what is actually do in this inner traversal, we will store all the value like all the variable like all the value that is exist in the binary tree in any array or vector. So after storing that all the value in the binary tree, we will return simply the size of binary tree. That is the our answer. Okay. So we would just do it here only. Okay. So void in order root, and I will just define here. I will just define here like a list to store that uh, to store that the root to store that the all the values. And here I have forgotten to to write a base case here. Okay, so let me write the base case here. Return, return. Okay, it means that if we reach the null pointer, so we don't need to go left or right. So you have to stop there. That's why you have to return here because the type is we are assuming as void. Okay, so that is it. And if root equal to null, then return. And if this is not the case, then we will just go to the left, root dot left, list dot add root dot data, because here is the value is replaced with data. So we just this is just a variable. Here it is named as data. If it is named as value, so we have to write the root dot value. That is not a problem here. So in order, that is root dot value. Okay. So we have to just initialize the array list, and we have to just call the in order function. So after that, we have to just return the size of the list. That is the whole code. I hope this is compiled successfully. Let's check. Yes, it's compiled successfully. Let's submit it. Yeah, it's submitted successfully. But there is a simple catch here. So what is the catch here? If you carefully observe that to store the all the elements, we are taking reference of any array list. That is, if there exist n nodes, there exist n nodes. So if there is a space complexity would be of big of n. Okay. So can we optimize this? So let me ask you one question. Can you optimize it? So I hope yes, it can be done so easily. So let me explain that how it is done, how it can be done. So for that, we'll take like a simple. We will go through the simple recursive solution. So how is this possible? So first, before going to the coding part, I'd love to like explain with the like actually how it can happen. So what does it mean? If it does mean if we take the reference of second test case, because it is little bit bigger, so it will be very much like clear to you that how actually recursion can happen. So my approach is here that I will initialize. Let me write it from here only because I I will get lots of places. Okay. So if we make a helper function from the root element. Okay. So what can we do? I will check that it will first keep it will first calculate that how many nodes in the left subtree. How many nodes in the left subtree. After that, it will calculate how many nodes in the right subtree. And so the total answer it will return number of nodes in the left subtree, number of nodes in the right subtree, plus one. This will be the answer. This should be the answer. So how it happens? We will observe as per the test case. Okay. So if we first pass the from the main function, we first call the helper function as a root node, as an argument of root node. So what it will do? It will first go to the let schedule. That how many nodes? Please give me the answer that how many nodes in the left children. Into left, it will calculate helper. So 5 dot left. What is the immediate left children of 5? That is 1. Okay, 1. And after that, it will calculate for the right children also. For the right children. So it will ask the immediate right children of 5, that is 6. Please give me the answer that what is the size of the tree that is rooted on you. So what I have just said, I have just said it will ask 6 that how many nodes are there in your tree that is rooted on you. It means that if 6 is the root, then how many nodes are there, including 6 and all its left or right children, left and right children. It will ask 6 also. After that, whatever will be the answer, it will simply return left plus right plus 1. This is the simple recursive code here. So how this recursive code working here? So let me explain it. Like actually how it is happening. Okay. So let me take another slide. It will be more easy for you. So first, if we make the tree, first 5. 5 will go to 3 because 5 will go to 1. 5 will go to 1. It will ask, 1 will ask its immediate left children, that is 3. That is 3. Now 3 immediate left children is none. So so here we have to write another base case. If root is null, just return 0. Why 0? Because if root is null, there doesn't exist any nodes. So we have to return 0. Okay. So null will return 0. 0. Null will return what? 0 to 3. Okay. So now 3 has left children uh, as null will return 0 to 3. Now left children 3 has like it is 1 0, and a3 will go to again the right children. That is, what is the right children? Here we can see the right children of 3 is also 0, none. So uh, it will also go to the right children, and right children as null. It will also return 0. It will also return 0 to 3. Okay. So now left of 3 is 0 and right of 3 is also 0. So now it's time to backtrack from 3 to its parent. So what the 3 will return? So helper 3 will return what? As per the code, will return left 3 plus right 3 plus equal to 1 plus 1. So what will it will return? 0 plus 0 plus 1. That is 1. So what is the immediate parent of 3? So from the tree as I traverse, the immediate parent of 3 is 1. So as left and as 3 is the left children of 1, so left of 1, what will be the answer? The helper of 3. Yes, am I right? So what will be the answer? That is 1. Now we have the left answer. Okay. Then we are after backtracking, we are currently in 1. So 1 will again go to the right children. That is right of 1. That is helper of null, because right children is null here. So as null, we know that null returns simply 0. Okay. So it will return 0. Okay. Then after getting the left and right children, so it is time for 1 to return back the answer to its immediate parent, to 5. So what the left of 5 will be the answer? Helper of 1. Okay. So what is the helper of 1? Helper of 1 will be left of 1 plus right of 1 plus 1. That is what? That is 1 plus 1, 1 plus 0 plus 1, that is 2. So left of 5 is 2. And after that, the 5 will go to the right children. So what is the immediate right children? Immediate right children of 5 is 6. So now let me draw another for the right children's. So 5 will go to 6. After that, 6 will go to the immediate left children of it. That is what? That is 7. And 7 will also go the immediate left children of it. So what is that? What is that? Well, that is null. But as we know, the null is always return 0. So what returns? It will return 0 to whom? To 7. So 7 has now the left children. So left of 7 is what? That is 0. And 7 will again go to its right children. So what is the right children? Right children is also null. So, then this null will also return 0 to 7. So now what is the value of 7? The helper of 7 will be left of 7, right of 7 plus 1. So it is 0 plus 0 plus 0 plus 1, that is 1. So it is simple. And the 7 will return like the late children of 6. Late children of 6, that is 7. So the left children of 6, that is left of 6. Left of 6. So what is the answer? That is the helper of what? Yes, helper of 7. That is 1. Okay. Now it will go to the its right children. Right of 6. What is the right of 6? Right of 6 simply call what? What? Let me see the what is the right children is 4. So helper of 4. Then 4 will again go to its left children. So left of 4. And as it is null, so it will return 0. Then it will again go to whom? Right children. So right is also null, it will also return 0. Then after calculating the left and right children, it will return what? Left 4 plus right 4 plus 1. That is 0 plus 0 plus 1. So actually right of 6 now we have got that is 1. So it's time for 6 to return back the answer to the root. So what will be the answer? Right? What will be the helper of 6? That is left of 6 plus right of 6 plus 1. What is that? 1 plus 1 plus 1, that is 3. So if we carefully observe that, let me scroll this. Okay, let me slide it. Okay, yes. Now we have got the right, the right, uh, the right of 5 as well as left of 5. So we can now easily return the total size of the tree. So what is the total size? How many nodes are there? The total nodes will be left of 5 plus right of 5 plus 1. That is, how many are there? 3. So what is the left? Yes, 2. 30 plus 1, that is 6. So we have done the whole dry run here. Okay, we have done a whole write-down of the second test case, and we can show the answer is 6. That is the answer for here also. So I hope this is clear. Okay. So just we have to code it, and the code is very much simple. So how can I do that coding? It is very much simple as I have written the pseudocode. So let me like if first we have to write the base case. If equal to null, we have to return. Okay. And int of left, because we have to calculate the left subtree size. Okay. So get size root dot left. Okay. After that, we have to calculate the calculate what? Calculate the right subtree size. Root dot right. Okay. Then after that, we have to just make the left subtree size plus right subtree size plus 1. Why 1? Because we have to calculate also, we have to include this root node also. It will be just a code. Let me compile it. What is the problem here? Missing return value. Sorry. Then we have to return 0 here because the return type is 0. Return type is int. Okay. Yeah, it compiled successfully. Let's submit it. Yeah, it's submitted successfully. So I hope this is clear. So let's meet the next video. Till then, take care. Bye bye. And happy coding. Stay happy coding.